We are in Unit 6, Learning Objective 18 and 19. So Learning Objective 18 and 19 kind of go together. So Learning Objective 18 is to label the heat of fusion or vaporization on a heating and cooling curve. And then Learning Objective 19 is to draw and label a heating and cooling curve. So they go together. A couple of things. A heating curve is going from a solid all the way to a gas. It is an endothermic process, and it has a positive delta H. A cooling curve goes from a gas to a solid. It is exothermic, and it is a negative delta H. So I'm only going to do one of these, and then you can do the other one. So I'll do the heating curve, and then you can draw the cooling curve in. So the thing is if you're going from a gas or a solid to a gas, okay, obviously we have temperature on the y-axis. Energy, on this case, is going to be absorbed because we're absorbing energy in a heating curve. On the x-axis, on a cooling curve, it's going to be energy released. And then a couple of things here. A change of state, it is a straight line. Okay, so this would be change of state. And then a diagonal line, because you're changing your temperature. Temperature does not change during a change of state. A diagonal line would indicate a state, so solid, liquid, or gas. So then we start at the origin. I don't really care, like if it's negative, boiling point, whatever, that doesn't really matter. When you're drawing this, you're just going to label the different things that are on it. So you do a diagonal up. That would be all of the solid, and then a straight line across. This would be where we're melting. And then you go up again, diagonal again. This would be my liquid. Straight line would be where I am vaporizing the liquid. And then another straight line up, and this would be a gas. So labeling this here, you have your solid, your liquid, and your gas at each of the diagonals on here. This would be your delta H of fusion. Again, this would be positive here because we're absorbing energy. And then this would be your delta H of vapor. You can find your boiling point by going to where you are vaporizing here or boiling all the way across here. And this would be your boiling point. And then same thing if you go from the other change of state, so your fusion, this would be your melting point. Again, the change of state that's occurring at this point is melting. So when we go this way, we're melting. And this would be evaporation or even boiling. You could say it's boiling there. Now, this drawing a heating curve or a cooling curve can kind of help you in some of these problems that are like learning objective 17, to where you're using like to try and figure out how much energy is required, that type of thing. So if we start at a solid, like we start down in here, and then we go up into the liquid here. So like this is the whole energy change. We're moving from a solid all the way into the liquid. We would have to take into account 1, 2, 3 calculations to get us there. So anytime you're in a state, to determine the energy needed to get you to like the melting point or the boiling point, you are going to use MCAT. So Q equals MC delta T. Okay. And when you are doing a change of state, you are going to take your moles of your substance times your delta H of vapor or fusion. So moles times the vapor of fusion, Q is equal to MC delta T. Now, you have this particular thing on your periodic table. So if you go to your periodic table, you can find these quantities right here. Okay, so like Q is equal to MC delta T. This is going to be for state, so solid, liquid, gas. Delta H of fusion is going to be for melting or freezing. And then the delta H of vapor is going to be, or the heat of vapor is going to be for vaporization or evaporation or condensation. So evaporation or condensation, melting and freezing. So you use these on your heating cooling curves when you're going from a solid all the way to a liquid. So the big difference between the heating curve and cooling curve is the cooling curve, you're going to start high. It's going to have the same kind of thing. You're going to go down, straight over, down, straight over, down. So 2 straight lines and 3 diagonals. You're going to start at the gas. The middle is always going to be the liquid and the bottom one's going to be the solid. You're going to have negative delta H of fusion instead of positive delta H of fusion because energy is going to be released instead of absorbed. And then evaporation would be condensation and melting would be freezing. So those are the same thing. So this was learning objective 18 and 19, which was to label the heat of fusion and vaporization on a heating and cooling curve and to draw and label a heating and cooling curve.